Okay, so this afternoon we're going to move on to perpendicular and parallel lines. We're still in linear relationship chapter. We're going to have a look at perpendicular and parallel lines. Can we write down the title first? Okay, after you've written on the title, I'm going to plot different lines, yeah, using decimals. And I would encourage you to have a look at what's going on here. Then I'm going to ask you guys, let's do a think, pair, share thing. So y equals 2x, y equals 2x plus 1, y equals 2x plus 2, y equals 2x plus 3, y equals 2x plus 4, that'll do. And let's do some opposite, y equals 2x minus 1, y equals 2x minus 2, y equals 2x minus 3. That'll do, that's more than enough. Okay, your task is to think really carefully and to look at what did you notice. Anything you have noticed. Anybody? Yep.
They moved one along the
Yeah, notice that other lines, do the lines intersect each other? So what sort of things would they're not intersect, right? So what are they? What sort of the parallel? Very good. The parallel. Now, let's have a look at the equation. Don't talk. Let's have a look at the equation here. I've actually listed all the equation here. What did we notice things are in common? Anybody notice anything? Huh?
The gradient is
The gradient is the, what is it? What did you say?
2.
The gradient is,
Same.
what is it?
2.
Same, very good. Yeah, have we noticed that?
Yeah.
The gradient is the same. The lines are parallel. If you don't believe me, let's do another one, right? Let's change a little bit to say if what we've just discussed about is still true. What if we say y equals negative 3x? Y equals negative 3x plus 2. Y equals negative 3x minus 4, something like that. What have we noticed? Based on what we discussed just now, let's have a look. Does that pattern still hold? Is gradient the same? Is gradient the same?
Yeah.
Yes, obviously, right? Minus 3, minus 3, minus 3. What did we notice about the lines? They're parallel to each other, right? Yes? Very good. Can we go back to, I'm just putting some screenshots here, right? That's basically what we said just now. Can we, I'm going to write this on OneNote. Can you write down your book now? Let's say if two lines are parallel to each other, the gradients are the same. Shh. Using abbreviation, I'm going to write down if L1 parallel, that's a symbol for parallel, which you should have known from year 8. Line 1 parallel to line 2, then M1 equals M2. M is the gradient, which we said last week. Yeah? So this is a super important conclusion from today, which I'm going to highlight in yellow, only this part. If two lines are parallel, gradients are the same. The other way around is also true. If gradient is the same, then we know the lines must be parallel. Make sense? I'll give you another 30 seconds to write this down in your book. If line 1 parallel to line 2, M1 equals M2.
Wait, what's the first symbol?
L1 parallel to L2. basically means it's two lines are parallel to each other, the gradient must be the same. If the gradient must be the same, the two lines are parallel to each other. All good? Right, I'm going to move on now. Don't worry too much because this will be on OneNote, even after class, okay? Okay, let's going to have a look at another thing, which just watch really, really carefully and see what's going on, because I'm going to ask you guys, hopefully you draw the conclusion by yourself, right? So y equals 2x looks like this. Okay, super easy question. What's gradient? 2, very good. I'm gonna draw another one now. Watch really carefully, okay? What's gradient this time? Negative half. I got 2, I got negative half. What did you notice about the two lines here? Obviously that's parallel, right? What did it look like? The cross section at how many degrees do you think it's gonna be?
360.
It's 360.
Oh,
Really?
360.
0. Come on. 90 degrees.
90.
Fantastic.
Oh, what?
That one. That one. It's 90 degrees. Right? We call that perpendicular. We haven't drawn the conclusion yet. But now we know these two lines are perpendicular to each other. What we want to see is the gradient relationship. One is 2, one is minus half. Now I'm going to write down in here 2 minus half. Okay. Now I'm going to change the graph a little bit so that we can see more patterns what's going on. If I change to 3, I change to minus a third. If I choose 3, minus third. What can I tell about the gradient in terms of graph? Are they still perpendicular to each other?
Yeah.
Excellent. They're still 90 degrees, right? They still intersect each other at 90 degrees. Let's do another one, then hopefully we can draw the pattern. Let's draw 5x and negative 1 over 5. That's not what I mean. Okay. Are they still 90 degrees? It's still 90 degrees. Okay. Based on the patterns or based on the gradients between L1 and L2, line 1 and line 2, we know the graphical relationship in terms of gradient, they are perpendicular to each other, right? They intersect at 90 degrees. Now back to this. If I give you a hint, can you multiply these two numbers, what do you get? What is it? Come on. If I multiply these two, what do I get? Negative what? Negative 1. Fantastic. I multiply this to this, I get?
Negative 1.
Negative 1. Negative 1.
How good is that? I didn't tell you, you found out. Let's write down the conclusion. Let's write down the conclusion. If two lines are perpendicular to each other, if two lines are perpendicular to each other, m1 times m2 equals negative 1, which we have verified based on graphs. Yeah? Now, using abbreviation symbol, we say if line 1 is perpendicular to line 2, then m1 times m2 equals -1. Obviously, just like the parallel case, the other way around is also true. If m1 times m2 equals -1, now without thinking, we know the two lines must be intersect each other at 90 degrees. So this one I've highlighted in yellow. You pretty much need to know it by heart. When I say by heart, I mean as a fact, or just must know. Okay, I'm going to do plenty of examples after this. Move on. The question said we want to decide if the two lines are parallel or perpendicular. In other words, to decide if two graphs are parallel or perpendicular, we must looking at the gradient relationship. Yeah? So, first one is super easy. What's the gradient for the first one? Half. Yeah? Did you guys say half? I didn't hear. Sorry. Good. Half. So, the gradient is half for the first one. This one, I don't know yet. Remember last week I said, or 2 weeks ago, we said, excuse me, I must change into y equals mx plus b form. Then I will know. Yeah? Bit of a quick revision. So, 2y equals x plus 5. Excuse me. 2y equals x plus 5. Y equals x plus 5 divided by 2. Now hopefully, I should be able to separate in the form of mx plus b. Yeah? Then y equals mx plus b. From here to here, we need to build that skill that we should be able to separate the fraction. Then, what's the gradient? What's the gradient? Half. Easy. So this one, first one's half, second one's half. What's the relationship? Therefore, parallel. Yeah? Because two gradients are the same. Easy, right? Make sense? Does it make sense, everybody? Good? Let's do another one. What's the gradient for the first one? It's 3. So m1 equals 3. What's the gradient for the second one? Third. Right? Are they the same? Obviously not the same. Do I multiply, when I multiply them together, does it give me -1?
No.
Does it give me -1? No. So it's neither parallel nor perpendicular. Yeah.
Why does that have to be -1?
Well, we've seen that. We've seen that relationship here.
What if it was positive?
What if it's positive? Good question. What if it's negative? Sorry, what if it's positive? Now I can say it's not 90 degrees. Yeah? It has to be that m1 times m2 give me the -1 relationship will produce 90 degrees. Good. Excellent. Okay, so this one we've seen that first of all, we decide is it parallel? How do I know? Are gradient the same? Answer yes, parallel. Answer no, could be other possibilities, right? So, conclusion is neither parallel nor perpendicular. That's a just quick symbol. All good? People feel comfortable so far? Final question before we do the other type of examples. All right, these two. It's not that straightforward anymore. However, the principle holds the same. I want to find out m. Can you guys notice? Did you guys notice that I didn't even care about y-intercept? Yeah? Right? I didn't care about y-intercept. All I care is about the gradient relationship. So, first one. If I call equation 1, equation 2, equation 1, I need to change into y equals mx plus b. That skill we practiced from 2 weeks ago. Hopefully, we are pretty good now. It's basically changing y as a subject. Can you guys tell me what's the gradient from here?
Y is equal to
What's the gradient?
derivative.
Try again.
Minus
Minus 3 over 2. I do not care about y-intercept. Even if you got wrong, it doesn't matter. Oh, well, we shouldn't get it wrong, but even if you get it wrong, it does not impact your results. Yeah? We are looking at this number here. Make sense? You okay? Alright, let's have a look at the equation 2. We want to write down y equals mx plus b. So I'm going to leave y. So minus y is x, sorry. Minus y is minus x plus 2.
Isn't it?
Yeah? Then we said we want to leave y as a subject. But at the moment it's negative y. So I'm going to multiply negative 1 everywhere so that y becomes positive. So y is x minus 2. From here to here, people feel comfortable? I say this one more time. I'm multiplying negative 1 everywhere. So negative becomes positive. Positive becomes negative, etc. Sorry, negative becomes positive, etc. All good? What's the gradient for this one? What is it? 1. Very good. 1. We don't write the 1, yeah, but it's 1. So once again, what conclusion can we make? Are they parallel? Are they parallel? Are they perpendicular? Are they perpendicular? No, very good. This times this obviously does not give you negative 1. Yeah? Okay. Move on. Now this sort of thing are quite important for your assessment task later on. Find the equation of 9 that is parallel to this and passing to this point. If you still remember, or if you did your homework from last week, we would have done find the equation of 9 that is passing to the point and giving a gradient. Today is exactly the same thing, just a little bit of extra point that we're talking about parallel or perpendicular now. So we want to find the equation of the 9 that is parallel. So as soon as you see this word, what should I be thinking? What should I be thinking? As soon as I see this word. Gradients are the same. Fantastic. Very good. Parallel tells me my gradients are the same. That's what my brain should be thinking as soon as I just even read this word. Parallel tells me gradients are the same. Right? Then from here onwards, back to exactly the same last week's content. There's no difference from here onwards. What's gradient in this case? Negative 2. Fantastic, well done. Once you've done that, exactly the same as last week. Working out, there's no difference whatsoever. Every single step it's exactly the same from last week. So, gradient is negative 2. The point passing through here and here. I'm going to write down one more time, but identical to last week. Y is mx plus b. I'm going to substitute the point into the equation. That's my x, that's my y. We say this more than I don't know how many times last week, right? So what's x? X is 1. So minus 2 times 1 plus b is 9. I know this is easy. I know some of you can do this in your head, but do that substitution as well. So minus 2 plus b is 9. B is, what's b? 11. Good. Yeah? Therefore, you can make your conclusion. Therefore, y is mx plus b. You finish. Identical to last week. Tiny extra bit today. Last example, and we completely done. We want to find the equation of 9 that's perpendicular to this and passing through a point. Once I read this word, once I just even read this word, what's my mind tell me? Or what should I be thinking?
Grade.
Huh?
The gradient will be minus 4.
Yep, at the moment it's 3/4, right? What's my new gradient if I call that? What's my new gradient?
Negative 4.
Negative? Think about it, right?
Negative.
Somebody said?
Negative 1.
Let's try. M1 times M2 equals this. Sorry, what am I writing? M1 times M2 equals -1, right? My old gradient is this. My new gradient, that's what I'm supposed to find out. Yes? Yes or no at this stage? M2 equals this times M2 equals -1. Then this one equals this divided by that. All good? Hopefully we're okay. We are dividing by a fraction times its reciprocal. Then that's it. That's the full working out. That's your new gradient. That's your full working out. As we become more familiar with this, you do not have to write down the full working out. What's the quick trick? Have a look. All I have done is, originally is a positive. Yeah? In order to produce the -1, my new gradient has to be negative. Then all I have done is flip it. 3/4 becomes 4/3. Positive becomes negative. Done. Yeah? Am I making sense? No. All good? No? I'll come to help you out this. Most people okay? Good. Okay, so this is your new gradient. I'm working with this new gradient. I'm subbing this point. Once again, become last week. Now this is what I mean. If you didn't understand last week's content, this one you significantly struggle, and this will impact the day of tomorrow. So y equals mx plus b. Is it okay? What is xy? That's xy, that's the point. Yeah, from here, no more new content. Again, last week's stuff. What's x? X is 3 plus b equals -2. 3 is 3 cancel. What's b? -2 minus -4, right? So -4 plus 2 is -2. Therefore, conclusion, y equals mx plus b. Then you completely finish.
What the? Oh, I get it.